All right, so this is a fairly short one, and then we'll just jump into an example. But bearing walls are similar to a column. I can bear directly on a wall. And so I'm just looking, these are not shear walls, which have the lateral piece. I'm looking at walls that just have axial. Or you could put one arrow here, whatever you want. So it's like a series of columns. They're all attached, however you want to think of it. So if I'm just looking at axial load, that's my bearing wall. So I'm just looking at the load that's transferring from the top to the bottom. And this is a common, like in a house, instead of you could have columns, you can have these bearing walls or both. So bearing wall, and we talked about this a little bit when I was talking about studs, how there's standard lengths of studs, because the studs are the pieces that go from the top, we call this the top plate, and on the top, typical to have two pieces of sawn lumber there, a double top plate. Then I've got the bottom plate or the sole plate, and the stud runs between the two of them, and they end up at this size because that's exactly the right size to get the ceiling height that would be standard. There's two standard stud sizes depending on what ceiling height you want. Um, so I might have a door or a window in between these guys. So I got the studs and the plates. If I have a window, for instance, I'm going to have a window sill or a saddle. Okay. There's going to be a header. And so what's this header? The header is what is the window is interrupting how often I space my studs. So those might be, well, we'll get to that when we do these, but these are at a regular spacing on center. And then suddenly I have a larger opening. So I'm going to need the header, which is what allows the load to transfer from where the stud was and, oops, from where the stud was, and they'll call that a cripple. That's just the piece that's going straight into the stud, and likewise on the bottom, so that I can continue to carry the force down to the ground. And I need a little stronger member to do that. If this isn't done, you don't have a strong enough header here, you'll see problems. We had a cabin actually at one point that the headers they just basically didn't put in headers. There's just a thin board here, or they, in one case, just put the window in and kind of left it hanging. Bad idea. It's going to mess up this whole area, settlement or worse problems. All right, so this is, the main piece here is we're going to have these studs. We're going to have at a certain spacing, and we're going to have a double top plate, a single bottom plate, and then any windows or doors. And you see the door also has a header and a cripple, right? So what's our capacity of a bearing wall? We've got this basically acting as a unit of the plates and studs together. Okay, so I'm not really thinking of these as little individual columns necessarily. They're part of this wall system. So axial load of sawn lumber studs, similar to column design, except for I'm going to have the bracing between all of these, right? So I said they didn't act as a column. They do. They're individuals, but the whole unit provides what a column would typically provide. So I've got those, if I'm looking down now, here's my individual studs, and then I'm going to have a sheathing here, and then drywall on the inside. Okay, so axial load, differences between this and a column. So I'll have a sheathing attached to the stud directly, and this actually forms this up. So you can start looking at this more like a single cross section that's almost like a box or something like this, but this helps stabilize these from being individual little columns, and this prevents the y-axis or the weak axis buckling, right? So here's strong axis, weak axis. So I'm not going to get these things going sideways, which is great. And then the stud capacity is based on slenderness ratio around the strong axis. All right, so I'm most effectively using these studs. So if they were individual columns, hopefully I'm making some sense here, and I have these two, right? Here's the weak axis buckling, and so it would want to go in this direction here. But because I've held it with the sheathing, it's not going to go back and forth here, which means when I actually get buckling, it would be wanting to go around, this is the strong axis, back and forth this way, but I've got this whole unit to resist that. All right, so the capacity of an individual stud is just going to be the effective length over depth, but in this case, I only have to use the strong axis, so that's nice. So looking at an individual unit, we just look at the strong axis. All right, so the other piece that we have to do here is not just look at the studs, who, while they're in a unit, we, conservatively look at one just in its strong axis bending. We also need to consider the bearing capacity of the top and the bottom wall plates, right? So the studs, so here's my double top plate, my bottom plate, and here's my studs. I'm not going to put a door in this one. The studs bear directly on the bottom, right? So this is on the ground or on the slab or on the floor below. And so I've got crushing as one option perpendicular to the grain. And then the floor or roof joists could be bearing directly down on the studs, or they could be coming in between, right? So if they're bare on the top plate between, that's going to be a bending of this top plate. If they're bearing directly onto the studs, that's now crushing of the stud. Okay, so those are the different things that can happen in a bearing wall. Right, so I've got the individual studs, which I'm kind of looking at crushing or buckling out in the strong axis direction. And then I also have the issue of the plates that I have to deal with. In other words, the top cross members. If the loads are coming down between the studs, that kind of buckling. So it's nice if they can all be lined up and things, but that's not the reality because I may have different uses for these different floors. If you don't have that sheathing directly to attached, then you're going to want to block it against that y-axis buckling. So something in here to keep it from moving side to side. But typically that sheathing is going to be attached to the studs. All right, so we're going to do a bearing wall as in our example, but before I'll do that on a separate item, so you can go back and look at it when you need to while doing your homework. But the easiest way to go through this is to just go ahead and work through these, okay? Next, we'll be doing, basically adding the bending part into this. All right, so I'll stop here and then